Okay, describe the charge distribution in this molecule. Okay, so there's 3 fluorines and 1 nitrogen. So wouldn't it just be an N in the middle with 3 around it for fluorines? And fluorine has a -1, nitrogen has a -3. So the nitrogen half would be more. So you would put the plus side, the plus side tail, and then it would go down.
Oh,
is that what it's talking
yeah.
about?
Or no, it would go this way. They all point towards the most electronegative. And so, since fluorine's more electronegative, he kind of hogs the electrons in this bond, so it'll be partial positive.
Wait.
Or,
right.
Sorry, negative.
So.
That would be partially positive.
No, it does. Okay. Oh, okay. So fluorine's more electronegative, and I was thinking nitrogen would be because it's got like a bigger, like -3, but because this is so much closer to being able to like get another electron, right? It means that there's like greater energy?
Yeah, I don't know why fluorine's more electronegative, but he just is, and so he wants the electrons more than nitrogen wants them.
Okay.
So these 2 electrons end up spending a little bit more time over here, same thing over here.
Mm-hmm.
So then fluorine becomes partially negative with these bonds, and nitrogen is partially positive.
Okay, so like that.
Yeah.
Okay. Is invalid. Identified error. Okay. So carbon and oxygen. So the octet rule. What is it? Isn't it just satisfying the valence the shell, or?
Pretty much, yeah.
Okay.
Each atom, in most cases, want 8 electrons surrounding it.
Oh, okay.
And so you count like, really if I were to draw out all the electrons, they look like this. These guys have lone pairs, and that's just a bond. I'll redraw those. So nitrogen in this case, he has 1, 2, 3, 4, 5, 6, 7, 8 electrons surrounding it.
Mm-hmm.
And all the fluorines have 1, 2, 3, 4, 5, 6, 7, 8. So they're all comfortable.
Okay.
So the octet rule is just making sure everybody has 8, including bonds.
4, 5, 6, 7, 8. Okay, well, that doesn't have 8, right?
Yep.
Wait, it does?
Yep.
Okay. So, it must be wrong electron total.
Yeah, and you calculate that. Oxygen brings to the table 6 electrons because you have 6 valence.
Mm-hmm.
And you have 2 of them, so that's 12 electrons from oxygen, and carbon brings 4. So that's 16 total electrons. There shouldn't be any more.
Mm-hmm.
And you have...
12, 13, 14, 15, 16, 17, 18, 19, like 20?
Yeah, so you have wrong electron total.
Okay. I think I can... 1, 2, 3, 4, 5. No, there's 8 on that. But did we want... Yeah, we did want 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's more than 8
Yeah.
fluorines. And I know that you can like go above the octet rule if they have like an open like p orbital or
D
something.
orbital.
Okay.
Mm-hmm.
1, 2, 3, 4, 5, 6, 7, 8. So that's just the wrong number, right?
Yeah, how many should it have?
Shouldn't it have 9?
Nope.
Wait.
Valence electrons.
Oh, valence electrons. So it has, wait a minute. So it has 7. Yeah, 7. So dumb, I keep trying. Okay,
Mhm.
7.
And there's 2 of them, so there should be 14.
1, 2, 3, 4, 5, 6, 7, 8. So there's not enough.
Mm-hmm.
Okay. Okay, so with this bracket thing and the negative, like, what does that mean? Why?
There's one extra electron.
Okay. So I've seen like when they have maybe not one, but like two, they put it like on the diagonal of this or something like meh, meh, or like it didn't really like match up, if that makes sense. You know how like, I guess my question is, when do you do like the bracket in the negative, or when do you like stick them somewhere?
You can do it either way, because what happens is that, well, that's just a wrong Lewis structure. Well, I guess, well, let's see. Well, let me think. You have, let's see, if we do formal charges, nitrogen has 1, 2, 3, it's a +2, yeah. So you'll learn how to do formal charges, but basically what that is overall, each of these guys has a minus, because they all have 1, 2, 3, 4, 5, 6, 7, or no. Hold on. Formal charge is split the bond. 1, 2, 3, 4, 5, 6, 7, and it should have 6, yeah. So you do 6 minus 7 equals -1. Oops. So that's a negative charge, that's a negative charge, that's a negative charge. And then nitrogen, he has 1, 2, 3, he should have 5. So 5 minus 3 equals a +2. So overall, the charge distribution, because this cancels out with 2 of those, so overall the charge is just a negative.
Okay.
And so they'll just write it like that and not place these charges, expecting you to just know that that's how the charges work. It just saves time.
Alright.